Okay, what we've got here, we've got like an application question for logs, kind of like an application question. This is kind of like what we'd see. I think they've started to do these, not started to do these, but I think they've done these in exams where it's something to do with a graph or a function or a derivative or something like that. And they deal a lot with A's and B's and things like that. And it's a little bit more abstract than what it normally will be. So we're looking for a tangent to a curve with the equation y equals log to the base ex at the point A and log e of A passes through the origin. And I want us to find the value of A. Now, looking at that, I'd normally say, how am I going to find the value of A? I'm not given any other information. Well, what I'll do, the first thing I'll do is I'll graph this. So if I graph it, it gives me an idea as to what I'm looking for. So I'm going to put this graph here, and now I'm going to graph log to the base e of x, because it's a function we deal with. So that's going to do something like this. Now, there is a tangent at a and log to the base e of a. So I'm going to put that here. That also passes through the origin. So over here, we're at a. Don't know how well I can draw this. And log. No, not working. Okay, so that's at this set of coordinates there. A log to the base e of a. And it's passing through the origin here as well. So now, what that does is that tells me that I've got a gradient of, I know this distance here is a, and I know the height is log to the base e of a. So I can say that my gradient, m, rise over run, is log to the base e of a over a. Then, what I'm going to do now, the other thing we know if we're dealing with tangents and gradients and things like that, is we want to find a derivative. So, we've got that. So then implies that dy dx equals 1 over x. So now, at this point, a, so the gradient at x equals a becomes 1 over a. That's just what it is. So now, we've got one gradient, we've got the same gradient. So what we can do, we can let these equal each other. So I'm going to say log to the base e of a over a equals 1 over a. So from there, given that a is equivalent to a, that means that log to the base e of a has got to equal 1. So from there, we'd say that a equals e. So just to recap, we've got our function, draw a graph to give us an idea what it looks like. Then it tells us there's a point, a and log e of a. That's where a tangent is. So that's where our tangent goes, it passes through the origin. So that tells me I know we're going to have a gradient here of a and log e over a. So that's what we've got there. And that's what we can define it here. The other thing we do, differentiate. So we differentiate this, and we find that at that same point, at a. So from there we can say log e to the base a over a equals 1 over a. They're the same, so these two have to be the same. And as a result, a has got to equal e, because log to the base e of e gives us 1. But like I said, this is kind of like what they do in the exams. There have been a number of questions like this, where they don't necessarily give you much information. They'll give you something like this, and they expect you to solve some stuff. The other thing they'd like to do is they may give you a number. So they may have 1, and so then log to the base e of 1, and then they'll try to generalize it. I'll ask you to generalize this by turning this into by substituting a or something like that in there. So it's a very popular thing that VCAR like to do. Make sure you can get your head around these things.